Hello students, how are you? I hope you all are doing good. So we are back again with the third lecture of the depth chapter, light, shadows and reflection. We have already covered 2 lectures of this chapter. Yeah. So this is basically the third and last chapter or last part of this chapter, light, shadows and reflection. So yeah, so in the previous class, we have already discussed about types of mirrors. Yeah. Then we see laws of reflection, what is reflection, that we have also seen. Yeah. In the final, we have seen what was plane mirror, and we have also seen terminologies related to laws of reflection, and we have also seen properties of image found by the plane mirror. So these things we have already seen already. Yeah. So we are now concerned with the final lectures. So let me share my screen. Okay. So today we are going to cover some certain topics, showing you what are the topics. We have already covered most part of this chapter. We are now concerned with the last part now. Okay. So now these are the topics we are going to cover today. That one is the real and virtual images. What are real virtual images? What are direct upright image? What is magnified diminished image? We'll talk about some concave, convex mirrors and their uses. Yeah. So I think we have got some basic idea already in the previous class about these terms. We will get into detail about these terms now. Okay. So first let's start the discussion with the topic of real and virtual image. So one image is real and another one is virtual. So what is the basic difference if I give you? Real image is that image which can be formed on screen. Yeah, which can be formed on screen, or you can say it is always formed. It is formed in front of the mirror. In front of the mirror. So you can also say the same side of mirror on which the object is present. If the image is formed on that side, then the image is real image, and this virtual image is formed behind the mirror. Formed behind the mirror. So this is the basic bifurcation, that real image is that image which forms in front of the mirror, or you can say same side of object. Same side of object. So this is the real one. Virtual is named as virtual because it is forming behind the mirror, and behind the mirror there is no part basically. You are just assuming that image is forming there. So what is the example of virtual image? Virtual image is a basic example of plane mirror. Whatever you see yourself in day-to-day life in front of the mirror, that is the virtual image. Yeah, that is the virtual image. Okay. So now another thing between real and virtual image is that for real image, light rays should actually meet at a point. Light rays should actually meet at a point. Yeah, because it already told you when the image is formed, when the light rays actually meet each other. Yeah, so there can be a case where light rays is coming after reflection like these. So this is one light ray, this is another light ray, and they are meeting at a point P. So image is formed at P. So this image which is formed by actual intersection of light rays is known as a real image. But there can be a case like this also, where this is the first light ray, reflected light ray, this is another reflected light ray. So if you see, they will never meet each other because they are kind of diverging. Yeah, they are kind of diverging in nature. Yeah, so that's why they will not meet actually. So if you have to make them meet, you have to extend them backwards. You have to extend them backwards. Okay. Stop sharing this. Yeah. Now clear. So I have we have been on the virtual image that if you are extending it backwards, what you will see a image like this. So I'm actually making the light rays to come backwards, and they are now meeting at a point. So this is the point where light rays were not actually meeting. We are making it to meet at a point by extending it backwards. The image formed is now known as virtual image. So in virtual image, light rays do not actually meet. Yeah. But in real image, light rays actually meet at a point. So light rays do not actually meet. Light rays do not actually meet, or you can say they appears to come from a point. They appears to come from a point. So you can see in the diagram also they appears to come from point B. They are appearing to come from point B, but they are not actually coming. We are extending them backwards. So this P is a virtual image and this P is real image on the left. So I think the basic bifurcation between real and virtual image is clear, that real image is always found in front of the mirror or same side of the object, and virtual image is found behind the mirror or opposite to object. Yeah. And real image, light rays actually meet at a point, but in virtual image, light rays do not actually meet, or they appears to come from a point. So you are making them to appear from a point by extending them backwards. They are kind of diverging, virtual. In case of real, they are kind of converging, so that they will meet at the point. So I think the basic bifurcation is clear between real image and virtual image. Yeah, there can be mirrors which form real image, there can be mirrors which form virtual. But one thing we have already studied in the last lecture is that plane mirror always forms virtual image. That was the property of plane mirror or image formed by plane mirror, that image formed is always virtual. That's why you will observe yourself in front of the mirror and your image will be behind the mirror. But that is actually behind the mirror, that is virtual image. Okay, now let's see the more clear distinction between real and virtual image with the help of a video. Yeah, so we are going to watch a video. From there we are going to learn this concept.
Basic understanding of the two virtual and real images. It's a slightly long video, but it'll be one of the most interesting ones too. I'm sure for it.
Okay, so we are going to learn the basic distinction between real and virtual image in this video. Okay.
Mirror. It has this plane and smooth reflecting surface on one side.
So you can see this is a mirror which has a plane and a smooth surface. So which mirror this is? This is a plane mirror. Yeah, this is a plane mirror. So now first we are talking about plane mirror.
It's called a plane mirror because its reflecting surface is flat. What other types of mirrors have you seen? Have you seen this type of mirror?
Yeah, so this is talking about types of mirror. So we have already seen there can be a spherical mirrors, there can be plane mirror. So whatever you are seeing in this video right now, in this picture, is the spherical mirror, not the plane mirror, because it has a surface which is not spherical. Let's see how it is.
You must have seen it on the stand of your bathroom, or maybe hung up there on the wall. This is not a plane mirror. Try to move your hands over the surface and you will notice it. This is called spherical mirror, or more precisely, spherical concave mirror.
So this is a spherical concave mirror because if you touch your hands on the mirror, you will feel, if this is a straight surface, you will feel the surface is straight, so that will be a plane mirror. But if the surface is not straight, it is kind of curved surface, then that mirror comes under the category of spherical mirror. So what is the property of concave mirror? It is curved inwards, yeah, and convex mirror is curved outwards.
As we use it mostly when we are shaving. Now the obvious question that must be coming to your mind is, why do we use concave mirror for shaving?
So now the question arises in your mind is why we use concave mirror for shaving mirror. That answer we will look later when we will go into detail of concave mirror. Yeah.
Mirror. For the answer to this question, you have to wait for our future videos. For now, we will be concentrating on the plane mirror only. So let's consider this plane mirror again. When we stand in front of a mirror, we see an image of ourselves in the mirror. Nothing surprising there. Why are we able to see our image? Yes, it's due to the reflection of light.
So what you are seeing in this picture is the person or a boy standing in front of a plane mirror and he is observing his image in the mirror. So I already told you that what was the reason for image formation, that is due to the reflection of light, because when light rays reflect, they will meet at a point, or actually they meet at a point or they appear to meet at a point. So if they are actually meeting after reflection, you will get a real image. But in the case of plane mirror, they will not actually meet. They will appear to come from a point. That's why you will get a virtual image in case of plane mirror.
But it's due to multiple reflections of light rays. How? The light rays.
Now see how the image is formed in case of plane mirror by multiple reflections.
Our first incident on our body. They bounce off from our body and fall on the surface of the mirror and again gets reflected somewhere. This reflected light then reaches our eyes and we see our image.
So this was the basic phenomenon of image formation, because your body is a non-luminous object. Your body is a non-luminous object. So light from a source of light or luminous objects will fall on your body and get reflected from that and incident on the mirror, and that incident ray will again get reflected and reaches your eyes. So whatever you are observing yourself is due to the reflection of that light ray which is incident on the plane mirror after reflection from your body. So from the source, light will come to your body, it will get reflected, the reflected light will incident on plane mirror, and then due to that light ray, one reflected ray will be found which is finally reaching your eyes. So that is the process of image formation basically for non-luminous bodies in day-to-day life.
What does this tell us? Yes, this tells us that a light ray can get reflected multiple times.
Yeah, you can again see there are two reflections happening here. One reflection was from the source hitting the human body, getting reflected, and the second reflection was at the plane mirror. The reflected ray from the man is acting as an incident ray for the plane mirror, and it is again getting reflected at the plane mirror. So there are two reflections happening. So a light ray can get reflected multiple times. This is evident from this example.
For every other non-luminous object as well. If you remember, my initial goal was to explain what virtual and real images are. Let me ask you a question. This image that you see here, is it a real image or a virtual one?
Yeah, so asking the question, is it a real image or virtual image which you are observing in case of plane mirrors? Yeah, and you already know the answer, that is a virtual image. Yeah, but we will see how the virtual image is actually forming by multiple reflections. And multiple reflections happens in case of non-luminous objects, any non-luminous object.
This image is a virtual image. In order to explain what a virtual image is, let's first simplify this image. Represent this boy with an arrow pointing up, and here is up to the mirror. You can assume the top of the arrow to be the top of the head of the boy. So where is the image of the boy from? When we see the image in the mirror, it seems to us that the image is from somewhere behind the mirror.
So what is happening here? You assume that the boy is looking like this in the diagram which we are using, ray diagram. The arrow or top of the arrow is showing the head of the boy, and the bottom of the arrow or tail of the arrow is showing the legs of the boy. And this is the boy standing in front of a plane mirror.
But there is nothing behind the mirror, right? For us, the light rays seem to come from the location present behind the mirror.
So what is happening? You are observing your image behind the mirror, but actually there is nothing behind the mirror. So there is something appear to come from there. That's why the image is forming as virtual image, because it appears to come from behind the mirror.
For instance, consider a few light rays emerging from top of the arrow. All these rays...
Now what will happen? Two light rays have been taken from the top of the arrow or the head of the boy, and they are incident at different points. So now if they are incident, they will follow laws of reflection, that is angle of reflection equals to angle of incidence, yeah, and they will reflect accordingly. Now see how they will reflect from the plane
on the mirror and get reflected back. Yes, all the reflected rays.
Now these rays which are getting back are known as reflected rays. One will reflect back along the same direction and one will get reflected in this direction.
Follow the laws of reflection. You see that all the reflected rays are moving away from each other. That is, they are diverging. But we know that the image is formed somewhere behind the mirror. So
now see, these two reflected rays are actually diverging. If you want to make them meet in actual, they will never meet each other because they are kind of diverging to each other. So you will have to extend them backwards to make them meet at a point. So that point where they will appear to meet after extending backwards is behind the mirror. That's why you are getting virtual image.
Send these reflected rays backwards and see what happens. We see that they meet at this point behind the mirror. And to us, this is where the top of the image appears to be. When we look at this point, it appears to us that all the light rays are diverging from this point. But in reality, there are no light rays behind the mirror.
See, what you can observe that light rays are coming from this point if you extend it backwards and meet it there. So light rays appears to come from this point behind the mirror, but there is no actual point present behind the mirror. So this is the virtual image.
Being a smooth and shiny surface reflects most of the light back, and almost no light reaches behind. But yet, we have the perception that the light rays are coming from the point behind. So we just consider the top of the arrow here. We can do something similar for the remaining points on the object to get the
So the remaining points of the whole body will get reflected in the same way, and if you extend them backwards, you will get a point like this, similar to this boy. But yeah, behind the mirror and not actually meeting. So it's a virtual image.
So we say that the image formed here is virtual, or in other words, not real. You can think of a virtual image as an image which appears to be formed in a position somewhere behind the mirror.
So yeah, we have already seen image which is forming behind the mirror is known as virtual image, in which light rays do not actually meet. They appears to meet or come from a point.
In reality, it isn't there. A virtual image is formed when the light rays diverge after reflection from the mirror. Every plane mirror forms a virtual image.
So this thing is clear. Every plane mirror forms a virtual image in which light rays do not actually meeting. They appears to come from a point.
This is the first characteristic of the images formed by plane mirrors. Images formed by plane mirrors are virtual and not real. So what is the real image then, and how are they formed?
Now we have been clear about virtual image. Yeah, now we are seeing what is actually real image then. If virtual image is formed by plane mirror, then what is real image?
Let's replace this plane mirror with a spherical concave mirror.
Now we are replacing the plane mirror with a concave mirror now.
Why? It's because real images can be formed by concave mirrors.
Concave mirror forms real images, that we'll see later. Yeah, so we'll see how images are formed actually.
Consider the light rays from the same point of the object incident on the mirror.
Now we'll see one light ray was coming from the boy, head of the boy. It was getting incident on the concave mirror and it was following laws of reflection and getting reflected like this. Another light ray was there. It was again getting reflected from the mirror following laws of reflection and meeting at a point like this. So if you can see, they are actually meeting at a point. They are actually meeting at a point. So whenever there is actual intersection of light rays, there is an image which is known as a real image. So that's why real images are formed in case of concave mirror.
We say that after reflection, each plane is What difference did you notice here compared to the plane mirror reflection? In the previous case, all the reflected rays were diverging. Yes, here all the reflected rays after reflection are intersecting each other at this point, or we can say that they are converging at this point.
So what is the basic difference? In the previous case of plane mirror, rays were diverging, yeah? So they were not actually meeting, but yeah, in this case of concave mirror, after reflection, rays are converging towards a point and meeting at a point in which or at which real image is being formed.
The image of the top of the arrow is formed at this point, and we can do something similar for the remaining points of the object too. We get this image. This is called a real image.
So in the same way, you can draw multiple reflections from every part of the boy and you will get a real image from this, yeah?
When light rays converge after reflection from the surface. One important thing we need to know is that real images formed by concave units are always inverted. We will learn more about this in the future videos.
Now I think the basic concept is clear. What is real image, what is virtual image? Real images are formed when light rays are actually meeting. It is always formed in front of the mirror. And if I talk about the virtual image, virtual images are formed behind the mirror. Yeah, virtual images are formed behind the mirror where light rays do not actually meet. They appears to come from a point. Yeah, that's why they are known as virtual image. Okay, now I think basic bifurcation of real image and virtual image is clear. So you can see now we have already seen this diagram that this is the real image in which light rays are actually meeting. Yeah, light rays are actually meeting, and this is a virtual image in which light rays extend backwards with a dotted line and they appear to come from a point to reach the eyes of observer. So that's why it is known as virtual image. Okay, so I think the difference between real and virtual image is now clear to you. Okay, now see, this is the second property we are concerned with. We have already seen what is real and what is virtual, and there is another term which is known as diminished or magnified. So name is suggesting diminished means smaller. Diminished word seems to be similar to smaller, and magnified means magnification. You use magnified glass in daily life, yeah, in experiment magnified glass. So why we use magnified glass? To make the objects look bigger, yeah. So in magnified means larger image. So whenever suppose this is object, this is object. So whenever you see the image of object of bigger size than the object, this is the image of this apple which is bigger in size in comparison to this object. So whenever the image is bigger, it is known as to be magnified. So in this case, you will say the image formed is magnified. Magnified means larger than the size of the object. Clear? And in the right part, if you see, the image of this apple is forming as a smaller image. Yes or no? This is of size smaller than that of the objects. So whenever the image formed is of a smaller size than the object, it is known to be diminished. So we use magnified word for larger image, larger than the object. Okay. And we use the diminished word for image smaller than the object. Smaller than the object. Okay. This thing is clear. That magnified means larger than the object in size, and diminished means smaller than the object. It can be a case where same size image will be formed. That will be known as image will be of same size. There is no separate word for that basically. We use diminished and magnified only. So I think this is also clear. What is diminished image, what is magnified image. Yeah, you can see in magnifying glasses also. Magnifying glasses will give you an image of the shorter objects as bigger objects. So you will be able to see them clearly. Yeah, so that is diminished and magnified image. Clear? Now the third property of images is erect or upright image. Erect or upright image. So we have a discussion about that already. Suppose this is the similar tree here. This is a tree. Yeah. If the image of the tree is forming like this, the orientation was here. This is the object basically. This is the image. So if the image formed is as the same orientation as the object, because you can see the top of the tree is matching with the top of the image, the bottom of the tree is matching with the bottom of the image. So that type of image which are as same orientation as the object are known as upright image. So this is the image which is upright. Means same orientation as the object. So what is then erect image? I think there is one word missing, inverted. Yeah, there is one word missing which is inverted. If you can see this image of the tree like this. So in this image what you can see, the top of the tree has just got inverted like this, and the bottom of the tree has got inverted to this point. Yeah, clear? So this type of image in which the orientation is just reversed is known as inverted image. This is known as inverted image. So upright or erect means same things. Upright or erect means same thing, means same orientation with the object. Inverted means opposite orientation of the object present. Clear? So this is the basic difference between erect and upright. So we have seen what are real, what are virtual images. We have seen what are magnified, what are diminished images. For larger image than the object, you will use the word magnified. For smaller images than the object, you will use the word diminished. If the orientation of the image is same as the orientation of the object, then the image will be erect or upright. Yeah. But if the orientation of the image is just opposite or reversed to the orientation of the object, then that type of image is known as inverted image. These are the basic properties of image, or different words we use for different types of images. So I think this is clear. Okay. Now we'll move on to types of mirrors then. So first one is concave mirror. So we have already seen that concave mirrors are those mirrors which are curved inwards. So what do you mean by this? If you carefully look this last diagram, these lines are showing the polished surface. So this is the non-reflecting or polished surface. You can use any word, non-reflecting or polished surface. Okay. And this front part, blue part, is the reflecting surface from which the reflection will take place. Okay. So the mirrors, or the type of mirrors which are curved inwards, or you can say the reflecting surface of that mirror is curved inwards, that mirrors are known as concave mirror. So you can see also, this is actually in 2D, but if you carefully observe in 3D, this is actually curved inwards, and this is actually curved inwards. So if you carefully observe, there is a girl standing, but the image which you are observing in the mirror is that the girl is upside down. Yeah, girl is standing upside down. So in this case, inverted image is forming basically. The orientation of girl was just reversed, but the image which is forming is inverted because the orientation has just reversed of the girl. Same is here in the second image. You can see the reverse orientation of all the furnitures and lamp present here. Yeah, all the lamp and furniture which are present here, you will see in the reverse orientation. So this is also inverted image. So basic property of concave mirror is that it forms real and inverted image. It forms real and inverted image. Okay. In maximum cases, concave mirror will always form a real and inverted image. There is only one case. There is only one case in which it will form a virtual image and enlarged image. It will form a virtual and magnified image. Yeah. There is only one case in which concave mirror will form a virtual and magnified image. Magnified means larger than the objects. So that is the point when the object is very near to the surface of mirror. Suppose this is concave mirror and the object is very near to the reflecting surface. Then in that case, virtual and magnified image will be formed. Yeah. Then in that case, virtual and magnified image will be formed. And you will see the application of this now. That what is the basic benefit of that. So concave mirror are those mirrors whose reflecting surface is curved inwards. They majorly forms real and inverted image. Yeah. But in one case, they forms virtual and magnified image in which the object is very near to the surface of the mirror. Yeah. This is basically a point which is known as focus, and there is a point which is known as pole. So if the object is kept between pole and focus of the mirror, then the image formed will be virtual magnified. We are not concerned with these terminologies, so we will not discuss these. But yeah, one thing you should remember, when the object is kept near to the reflecting surface of concave mirror, then the image formed will be virtual and magnified. In rest other cases, it will be real inverted. Clear? So now we'll see uses of concave mirrors. Basically, concave mirrors are used for inverted images. So this is the case. Dentists use this concave mirror to see the teeth or to observe the problems in the teeth. This is the headlight of a car. So in the headlight of a car, or you can say headlamp of the car, you can use the concave mirror because they will give a much sharper image or much sharper light on the road, because you need a light on the road which is focused at a point. As concave mirror forms images or light rays which are converging. Have you seen in the video that concave mirror was forming converging rays after reflection? That's why they were meeting at a point. So what you required from a light of in a car, you will require that all lights will converge at a point on the road. So you will get a much brighter light on the road and you will be easily able to see at the night. Yes or no? So concave mirrors are used in the headlamps of the car to get a more focused light at a particular point on the road. Okay. And dentists also used to get a real inverted image. This is the final application of concave mirror in which it is used as a shaving mirror. Shaving mirror. So what is the basic need or what is the basic application here? If you can carefully observe, you will have observed a shaving mirror in your bathrooms. So what is that? In shaving mirror, you will see a larger image of your face, or I can say magnified image of your face, but it is virtual because it is behind the mirror, because you are looking your face for shaving. So for have a better shaving, what you need a much clear view of your face. Getting my point? To get a much better shaving so that you do not get any cuts. What you need a much better view or much enlarged view so that you will be easily able to see the face. So for that enlarged view, you keep your face near to the mirror. Yes or no? We do not look like this. We always look on the shaving mirror like this at some appropriate distance, which is smaller. So due to that smaller case, I have already told you, there is one exception in concave mirror, that whenever the object is near to the surface, virtual enlarged image is formed or virtual magnified image is formed. Enlarged and magnified are the same things. So that virtual and magnified image is used for shaving mirrors because you are now easily able to see your face clearly with a magnified view. So you are using that application of concave mirror only one case, which is forming as virtual enlarged image as a shaving mirror. So that's why concave mirror is used in dentist mirrors for the purpose of getting better image. They are used in headlamps to get a more focused light because they form a converging rays. Their rays always converge after reflection from the concave mirror. And in the case of shaving mirror, you are using the concept of virtual enlarged and magnified image. When the object is kept near to the concave mirror, it forms a virtual and magnified image. So that you are using as a shaving mirror. So I think concave mirror is clear that it mostly forms real inverted image. Only one case, it forms virtual enlarged image, and that is used in shaving mirrors. Okay, clear? And its reflecting surface is curved inwards. Clear? Now the next is convex mirror. So convex mirror is just reverse of concave mirror. Now the reflecting surface is curved outwards. Now the reflecting surface is curved outwards, and this is the non-reflecting surface, which is basically polished surface. This is non-reflecting surface, which is basically polished surface. Okay, So now you can see this side view mirror, or this mirror has a side view that you can observe that it is outside bulged. Yeah, if you can carefully observe it is bulging outwards. So this is a kind of convex mirror, and you can see now the girl is looking at us straight, or you can say upright. The image of the girl formed is upright because it is in the same orientation as she is standing in front of the mirror. Yeah, obviously the image is forming behind the mirror, but it is upright, or you can say erect, means same orientation. And you can see also this diagram that this surface is also bulging outwards or curved outwards. You can see reflecting surface is curved outwards. So this is the convex mirror. Clear? So convex mirror has a property that it always forms virtual image. There is no case of real image here. Convex mirror always forms a virtual image and a diminished image. Virtual and diminished. So the properties of image formed by convex mirror is that it always forms a virtual and diminished image. Clear? So that's why whenever you are observing this image of a girl again, this girl as an image, she is standing upright or erect. Why? Because it has a property, it will form a virtual, diminished and erect image. So the complete properties of image formed by convex mirror is that it will always form a virtual. Virtual means rays actually not meeting. Diminished means smaller than the object, and erect. Erect means same orientation as the object. So these three are the properties of image formed by convex mirrors. So due to these properties, it has several applications. Yeah, so we'll see the application of convex mirror now. See, the basic application is in the rear view mirror. These two are rear view mirrors of the car. These two are basically convex mirrors, because convex mirrors has a benefit that they will form a light rays diverging like this. Suppose this is a convex mirror, light rays are coming, say they will get reflected like this after getting reflected. So they have a much larger field of view. If you can see, this is the field of view which the reflected rays are covering. Obviously the image will be formed somewhere out here, because you will have to extend it backwards, but the field of view is more. So due to the larger field of view, it is used in rear view mirrors of cars, so that you can get a better view of behind the car, whosoever car is coming. And you have already seen also in the daily life, in the practical application, that in the rear view of the mirror car, and you can also see in this image, that objects in the mirror are closer than they appear. Yes or no? You will always see this line written on the mirror that objects in the mirror are more closer than they actually appear. So what is the reason for that? Because this is a convex mirror, and convex mirror always forms image near to the surface behind the mirror. This is a property of convex mirror, that it always forms image near to the surface of convex mirror. So that's why even if the object is here, suppose the object is at I can say 100 centimeter. So the image will be formed at 20 centimeter only, for example. So you can observe that if the image object is at a larger distance, the image will be again at a slow near distance. So that's why it is written as objects in the mirror are closer than they appear. Okay, clear? So this is again one application. This is another application in parking. In parking slots, you have seen this mirror, which will be used to observe the cars coming from behind. And this is also the basic application. Somewhere about you can see outside a hotel also. This is marked outside a hotel. This type of mirror you can see. This is used to observe the cars coming from behind. So before entering into the hotel, you will get a clear view that which car is coming. So you can easily come out or go into the hotel with your car. So what is the basic use of convex mirror? It is mainly used as a rear view mirror in car due to its larger field of view. Okay. And it has a curved surface outwards, or I can say a reflecting surface is curved outwards, and convex mirror always forms a virtual, erect and diminished image of any object. So I think that today's discussion is clear about that what is real image, what is virtual image. Yeah, real image means actually meeting, virtual image means not actually meeting. Okay, and we have seen about diminished and magnified. Diminished means smaller size, magnified means larger size. We have seen virtual, erect. Yeah, we have seen what is virtual, we have seen what is inverted basically. So these are the properties we have observed. Okay, so I think this chapter is clear. We have covered all the concepts regarding this chapter. Okay, so I hope this was clear to you. Okay, so in case of any doubts now, you can refer to the forum at Ask IITians website. A forum is present, doubt forum, where you can directly ask your doubts. So I hope this is clear. So we'll end this lecture now. Thank you so much for your time. Bye bye.